Now that we have a server and a mock client, we need to connect them together. So we have a working prototype. We also need to implement some core functionality such as SMS activation. Before we get started, we need to add some things to the client project. First, we need to add the WebSocket's CN1 lib from the extension manager. This is pretty simple to do if you already added a CN1 lib before. Next, we need to sign up to Twilio.com as developers. They have a free trial account. Notice we don't need to install support for the Twilio lib since we already installed the SMS activation CN1 lib before. Notice that we are sending the SMS activation code from the client side. This is a bad practice. You should use the server Twilio API and send the SMS activation code from there. I chose this approach because it's seamless and shows the usage of the APIs on the client, which is what I'm trying to teach. However, keeping authentication code in the server is far more secure. You will need the following values from the Twilio developer account: account ID, SID account SID, auth token, and phone number. Make sure to pick a US phone number for the free account, otherwise payment would be required. Once you have those values, you can create a new globals class which we will use for the global application data. Notice you might want to replace localhost with your IP during development so you can test the device against a server running on your machine. The device would obviously need to be connected to the same Wi-Fi. The following values are the values we have from Twilio. For convenience, I used static import for these constants within the code. The user class on the client side mirrors the user DAO, but uses the properties syntax, so we can leverage observability, JSON, persistence, and other core capabilities. If you are familiar with properties already, you won't notice anything special about this class. It's just a standard property object. If you aren't familiar with properties, please check out the video covering them, as it would be helpful moving forward. We need to define a connection layer that will abstract the server access code. This will allow us flexibility as we modify the server implementation and the client implementation. It will also make testing far easier by separating the different pieces into tiers. The abstraction is similar to the one we have in the server. I chose to go with a mostly static class implementation for the UserService, as it's inherently a static web service. It makes no sense to have more than one user service. Once logged in, we will cache the current user object here, so we have all the data locally and don't need server communication for every query. We bind the user object to preferences, so changes to the user object implicitly connect to the preferences storage API and vice versa. Preferences allow us to store keys and values in storage, which maps every entry to a similar key value pair. Whether we are logged in or not, or out, is determined by the token value. We need that to send updates to the server side. I'm creating the 4-digit verification code and sending it via the Twilio SMS web service API. I'm also storing the value in preferences so I can check against it when it's received, even if the app dies for some reason. This method is invoked to validate the received SMS code. Notice I don't just use equals. Instead, the validation string might include the full SMS text. This can happen on Android, where we can automatically validate. Notice I still limit the length of the string to prevent an attack where a user can inject all possible 4 code combinations into this method. Maps to the user exists method in the server, which we use to determine add/login flows. I use the REST API to make a single connection with the get method. In this case, the response is the string true or the string false, so I can just check against the letter T. When adding a user, I use the REST API's post method. Here I can set the body to the JSON content of the user object. The response is a string token representing the user, which we can now store into preferences. The login method accepts a phone and password and is invoked after we've validated the phone. It can succeed or fail. If we get back a token, that means the user authentication exception wasn't thrown in the server, and we can set it into the preferences. Otherwise, we need to send a failure callback.